Chapter 8, Section 2, Solving Equations Using Square Roots. All numbers have both a positive and a negative square root. So if we take the number 9 and put a square root symbol over it, and we want to find an answer that we multiply by itself to get 9. One of the solutions is positive 3. And if you just see the symbol like this, then you're only asked to find the positive root. If you had this symbol, you're asked to find the negative root of positive 9. And that would be negative 3. Negative 3 is a root of 9 because negative 3 times negative 3 gives you positive 9. If you see this symbol, you're being asked to find both the positive and the negative root of 9. And you would answer it this way. Positive and negative. We'll talk a little bit more about this symbol in another slide. A little bit of terminology. Sometimes you hear people say the square of a number compared to a number squared. It means the same thing. If you start with a number n and you put an exponent of 2 beside it, that is the square of n. Or you could read it as a number squared. Kind of the opposite is the root of a number, or the square root of a number. Numbers have square roots and cube roots and other roots, but if you just hear root, it's used so commonly that it implies that you want the square root. So just a little bit of, these terms sound really the same, but they're different. The square of a number sounds a bit like the root of a number or like the square root of a number, but they're really not the same thing. This symbol, I said that we would get back to this particular symbol. This symbol means add or subtract or plus or minus. So if we had this symbol in front of a 7, it would either mean positive 7 or negative 7. This is really the gist of the lesson, how to solve equations. I just wanted to reinforce that the square root of 36 can either be positive or negative 36. But typically, if you just had this symbol, it would mean the positive root of 36. The equation here says that a number squared is 49. So when you're solving an equation, whatever you do to one side, you do to the other side, and that includes putting a radical over the number. So you can put a radical over n squared and put a radical over 49. Maybe you recall from previous lessons the theorem that says the square root of a number squared is that number. So that applies when we simplify the left side of the equation. The square root of n squared would be n. Now we don't know for sure if n is positive or negative, and we don't need to put this symbol in front of the square root of n squared. In fact, don't do it. There's a particular reason that you don't. But you do, as you're working down through it, at this step, as soon as you put the radical over n squared and put the radical symbol over 49, you should put the positive or negative sign in front of this radical, so that when you solve it, the square root of 49 is 7, you'll know that the solution is either positive or negative 7. So when you put this back into the equation up here, we would say that negative 7 to the second power is 49, and positive 7 to the second power is also 49. So that both positive and 7 are the solutions for n in the statement that n squared equals 49. And you need to state both of them, and the simple way to do it is just to use the plus or minus or the positive or negative symbol. So this is a two-step equation where x squared minus 4 equals 21, and we want to, if we knew what x was, we would first take x to the second power, and then we would subtract 4. So working backwards, we would say we have to add 4 to both sides first. Oops, should be a 4. And this is a very contrived problem, as you can see. So I wanted to get a perfect square. This would leave me with x squared equals 25. So I put the radical over x squared. I do not need to put the plus or minus sign outside of that, but I do need to put it here because it can be the positive root or the negative root. And so x will either be positive 5, or negative 5. And this symbol takes care of both of them. It's either positive or negative 5. And this is sort of a simple example. It doesn't have much arithmetic to do over on the right-hand side. There's no variables over here. It just says that the number that we're thinking of is either 3 plus 10 or it's 3 minus 10. So we could say that n equals 3 plus 10, that's a 10, or n equals 3. Sorry, I'm having a little trouble there. No, that's not going to erase, so we'll just go with it. 3, make it look like a 3, minus 10. And we solve this one, we get 13, n is 13. Let's do the keep, change. So we keep the 3, make it addition of negative 10, and n would be negative 7. So the two solutions are n is either 13 or n is negative 7. And then these two equations look very similar, but it's when to go over how you would solve this. We can figure out the square root of 121. Mainly, I wanted to point out to you that if you're not told that you want both positive and negative root, just assume you need the positive root. So this would be the positive root of 121, and here, this probably should be a little bit closer to the radical, but it does mean the negative root of 121. So 121 is a perfect square, which makes this fairly easy to do. The positive root of 121 is 11, because 11 times 11 gives us 121. So simplifying the square root, or the root of 121, we get 11, and 11 plus 4 will give us 15. So that's the only solution to this equation. Then when we do the lower equation, we would say that c equals the negative root of 121, which is negative 11, plus positive 4, and that simplifies to be negative 7. So that's just to stress to you that if you're asked just to find something like this, just find the positive root, and this would be the negative root.